The compound para-aminobenzoic acid, listed as PABA in bottles, much easier to say, and it's in sunscreen, is composed of the following elements by mass. We have carbon, hydrogen, nitrogen, and oxygen. Our task is to find the empirical formula of PABA. Let's start with step 1, a good place to start. We're going to convert the mass percentages of the elements to mole amounts in a hypothetical 100-gram sample. Right, that's this guy right here. We'll assume a 100.00 gram, we'll just add a couple sig figs there, amount of PABA to find the mass of each element. So since carbon was 61.31% mass percentage, well, we multiply that by 100 grams and we come up with 61.31 grams of carbon. And we do the same thing for hydrogen, nitrogen, and oxygen. And with any luck, these should add up to 100. You can check that, but pretty sure it does. Step 2. We know the representative mass. We can use the molar mass of each element to calculate the number of moles we have. So let's look at this table over here. We found this column on the previous slide, so if you'd like to review that, go ahead, and that totals up to the 100 grams of the sample. And then this chart, we take the molar masses, and we get this off the periodic table. So carbon, 12.01 grams, that's 1 mole. Hydrogen, the AMU converts over to grams, that's 1.01 grams. Nitrogen has an atomic weight, 14.01, and oxygen, 16. We do the mass, and what we have now, and we go out an extra sig fig, just we can fix that at the end and go back to what we're allowed, but we have 5.105 moles of carbon, 5.09 moles of hydrogen, and so on. So now we've done this, this, and this. And finally, we're doing the mole ratio. So this we have to be a little bit clever on. We look at our moles over here, and this is from the previous slide. Here's carbon, here's hydrogen, here's nitrogen, and here's oxygen. We take the smallest number of moles, and in that case that would be nitrogen right here, 0.7288 moles. We put that in the denominator of each ratio in this column. So you can see there, 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 and there. We then take the moles for each one of the elements. So here's carbon, put 5.105 there. Hydrogen goes over there. Nitrogen goes here, so that's easy. That's going to divide out and get 1. And yeah, there we go. And oxygen comes here. You divide out, and notice you do not get an integer. You get pretty close, so we're just going to go ahead and round that up or down depending on which integer it's closest to. And carbon, we come up with 7, hydrogen 7, nitrogen 1, because dividing a number by itself gets 1, and here's oxygen. And then we can write it like this. C7, there's the 7, H7, there's the H. Then we have N, just one N, and then we have 2 O's. So there we go. That's the empirical formula. It took us a few slides to do our first empirical formula, but let's show how you can actually do it on one sheet of paper, which is what we have here. Okay, we still have the same steps we did, we're just leaving out all the detail. So we have 1,6-diaminohexane, which is used in making nylon. Okay, that's interesting, we don't need it for this. Here is the mass percentages, and we want to find out the empirical formula. First thing we do, the mass percentages turn into grams. We are assuming a 100-gram sample. So there's carbon, 62.1, hydrogen, 13.8 grams, and nitrogen, 24.1. Next, we convert it to moles. So on the periodic table, carbon, AMU is 12 AMU. We convert that to 12 grams. Hydrogen has an atomic mass that we convert to 1 gram, and nitrogen is 14.01. So we have mole over gram times gram, and we find out the moles of each one of these guys. Who's the smallest? Is it 5.17, 13.8, or 1.72? It's 1.72. We divide all of the numbers in this column by 1.72, and we get this. The moles cancel, and the ratios we get, carbon is 3.01, approximately 3, hydrogen 7.96, approximately 8, and the nitrogen of course is 1. We're dividing 1.72 by itself. So we have C3H8N1, which is this. We don't have to put the 1 with the N. We can just leave it as N. So that's the empirical formula.